Assalamualaikum and hello everyone. My name is Arif Shami bin Asmali. My metric number is 702834. For this STIJK 3114 Network and System Security Final Assessment, I will present my project titled Phishing URL Detection using Python. This project explores how Python and machine learning techniques can be used to identify whether a URL is legitimate or potentially used for phishing. In this presentation, I will explain the security problem, the methodology, the URL features, the machine learning methods, the results, and how this detector could support a wider cybersecurity strategy. Phishing is a social engineering attack that mainly targets human trust. Attackers create links that look similar to genuine websites belonging to banks, universities, delivery companies, government agencies, or cloud services. When users open these links, they may be asked to enter passwords, banking information, payment details, or one-time verification codes. In some cases, the link may also begin a malicious download. Traditional blacklist systems can block known phishing websites. However, they may not detect a newly created link that has not yet been reported. This is why the URL itself can be useful as early security evidence. It can be examined before the browser loads the full web page. The aim of this project was to develop an understandable phishing URL detector, rather than making a black box security claim. The main objective was to build a complete Python pipeline that transforms raw URL strings into numerical security features. 4 major tasks were completed. First, I prepared a labeled dataset containing legitimate and phishing-style URLs. Second, I extracted 22 lexical and structural features from each URL. Third, I trained 3 machine learning models: Logistic Regression, Random Forest, and Gradient Boosting. Finally, I evaluated their performance using accuracy, precision, recall, F1 score, ROC-AUC, and the confusion metrics. This allowed all 3 models to be compared fairly using the same data. Previous studies have introduced several approaches to phishing detection. These include blacklist filtering, heuristic rules, lexical URL analysis, machine learning, deep learning, visual similarity analysis, and hybrid systems. This project focuses on lexical URL features because they are lightweight and can be analyzed quickly. The system does not need to visit a suspicious web page before making an initial prediction. This helps reduce exposure to potentially harmful content. However, the literature also shows that model performance depends heavily on dataset quality. Duplicate data, outdated URLs, incorrect labels, or unrealistic samples can produce misleading results. Therefore, reproducibility, recent data, and testing against changing attacker behavior are important parts of phishing research. The project follows a step-by-step Python workflow. It begins with a labeled URL dataset. The program cleans the records, removes unusable data, normalizes the labels, and checks for duplicate entries. Each URL is then separated into components such as its scheme, domain, path, and query. The program extracts the numerical features before dividing the data into training and testing sets. The 3 models are trained and evaluated, and the best model is saved for future use. The main software libraries were pandas and numpy for data handling, urlib.parse and regular expressions for URL processing, scikit-learn for machine learning, matplotlib for figures, and joblib for saving the selected model. The controlled evidence dataset contained 1,300 labeled URLs. There were 650 legitimate style URLs and 650 phishing style URLs, giving the dataset a balanced class distribution. From every URL, the program extracted 22 features. Examples include the total URL length, domain length, path length, number of dots, number of hyphens, number of digits, and number of subdomains. The program also examined whether the URL contained an IP address, suspicious words, a shortened link service, and unusual redirect pattern, or a suspicious top-level domain. URL entropy was calculated to measure how random or encoded the address appeared. HTTPS use was recorded, but HTTPS alone was not treated as proof that a website was trustworthy. During exploratory analysis, several differences appeared between the two classes. The phishing style URLs were generally longer and contained more hyphens, digits, subdomains, slashes, query content, and suspicious words. They also tended to have higher entropy, meaning that parts of the URL looked more random or artificially generated. These characteristics may appear because attackers tried to place a familiar brand name inside a longer or misleading address. They may also use redirects or shortened links to hide the final destination. However, one feature alone cannot confirm that a URL is phishing. For example, a legitimate website may also have a long URL or several subdomains. The model therefore combines multiple signals when producing its prediction. 3 supervised machine learning models were evaluated in this project. Logistic Regression achieved the strongest overall result. It recorded an accuracy of 0.9723, precision of 0.9576, recall of 0.9875, and F1 score of 0.9723, and an ROC-AUC of 0.9755. Gradient boosting produced the second highest F1 score at 0.9664, while random forest achieved an F1 score of 0.9632. The F1 score was used as the main selection measure because it balances precision and recall. This is important in phishing detection because the system must reduce both missed attacks and unnecessary warnings. The results also demonstrate that a relatively simple model can perform strongly when meaningful features and consistent preprocessing are used. The confusion matrix provides a more detailed explanation of the selected model's performance. Out of 325 testing records, the model correctly identified 158 legitimate URLs and correctly detected 158 phishing URLs. 7 legitimate URLs were incorrectly classified as phishing, creating false alarms. 2 phishing URLs were incorrectly classified as legitimate. From a security perspective, the 2 missed phishing URLs are the most serious errors. A false negative may allow a user to open a credential stealing or malware related page. However, false positives are also matter. Too many unnecessary warnings can interrupt users and create alert fatigue. Therefore, the detector should explain why a URL was considered risky instead of only displaying a general warning. One important evidence or objective of the project was reproducibility. The Python script performs data preparation, feature extraction, model training, evaluation, visualization, and model export. The evidence run generated several technical files. These include the working URL dataset, the table of engineered features, model performance matrix, a classification report, feature importance results, and the saved logistic regression model. It also generated figures showing the class distribution, differences in feature values, model comparison, and confusion matrix. Because the steps are included in one reproducible script, another user can run the same program with the same dataset and inspect the outputs. This provides a clear audit trail from the original records to the final prediction results. This phishing URL detector should not be treated as a complete security solution. Instead, it should be used as one layer within a defense in-depth strategy. The detector could be integrated into an email gateway, browser extension, secure web gateway, or security operations dashboard. A high-risk URL could be blocked, while a medium-risk URL could display a warning and ask the user to confirm before continuing. The warning could also explain the reason, such as a shortened link, an unusually long domain, multiple subdomains, or account verification wording. Other protections are still necessary, including email filtering, multi-factor authentication, password managers, security awareness, and clear incident reporting procedures. In conclusion, this project developed a complete phishing URL detection workflow using Python. A total of 22 lexical and structural features were extracted from URL strings. Logistic regression, random forest, gradient boosting were compared, and logistic regression produced the strongest F1 score, which is 0.9723. The results demonstrate that useful phishing indicators can be identified before a user loads the complete web page. However, model performance still depends on current data, correct labels, realistic testing, and continuous retraining. The main message from this project is that machine learning can support early phishing detection, but it should always be combined with other technical controls and user awareness. Thank you for listening to my presentation. My name is Arif Shami bin Asmali, matrix number 702834. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.